Okay, let's forget about distance time graphs for a moment and concentrate on functions in general. Let's say I have this straight line graph. It's this graph is y equals not mx, y equals 3x plus 1. Or I could even write f of x equals 3x plus 1. Right? Remember, they're the same thing. Now, I want to work out, let's say I want to work out the gradients of this graph at x equals 1. Okay, so at this particular point on my x-axis, x equals 1 is here. Go up, I want to work out the gradient here. Now the great thing about this graph is it's a straight line graph, right? And the gradient's the same everywhere. We actually know what the gradient of this line is, okay? It's 3, isn't it? Because this is the y equals mx plus c. It's a straight line. Whatever number's next to the x is the gradient, so we know it's 3. But we can show that it's 3 by just, if we want to work out the gradient at this point, well, it's the same anywhere, it's the same everywhere. So pick 2 points, let's pick this one up here, and create a right angle triangle like this, and your vertical step is, so your horizontal step is 2, and your vertical step is 1, 2, 3, 4, 5, 6. Okay, so do the vertical divided by the horizontal, and you get 3. And this is the same everywhere, because it's a straight line graph. The problem arises when you have graphs like this. Okay, so this is y equals x squared. Okay, or you could even write f of x equals x squared. Right, this is the function of x. This is x squared. Now, let's say I wanted to do the same thing. I want to work out the gradient at x equals 1. But you can see the gradient is not the same everywhere, okay, on this line, okay? It's not the same number, it's not 3. It might be 3 somewhere on this line, but it's not 3 everywhere. And the thing about this graph is that in some places the gradient even is negative, right? I mean, this side, any point on here, if I draw a tangent line at any point on this side, they're going to be positive values because it's going uphill there. But here, on this side, it's going to be downhill. And then at this point here, well, the tangent would be a horizontal line, the gradient would be exactly 0. So there's places where, the gradient's changing at every point on this line, okay? There are places where it could be 3 like before, but it's changing. So if we want to work out the gradient at, let's say, this point 1, x equals 1, here's 1 on the x-axis, go up. Right, what I need to do is construct, again, well, think about the principle of picking 2 points but making them smaller and smaller and smaller and smaller. Well, I'm just going to create a tangent line at this point here. So let me do that. Let me create a tangent line here. Let me try it as best as I can. That seems to be okay. Now let me try and work this out. So what number have we got here? We've got, that might be 0.5, and that's 2 there. So this is the gap of 1.5 here across. Okay, just picking this endpoint and this endpoint of my line that I've just drawn. Right, now the vertical step, let's try and figure out what that would be. Let's see. It is 1, 2, and maybe that's, I don't know, 2.8 or 2.9. Right, so I'll have to do 2.8 divided by 1.5 to work out the gradient at this 1 point here, using this tangent line, this tangent line that I've drawn by hand. Okay, so if I do that, 2.8 divided by 1.5 is 1.867. Okay, to 3 decimal places, 4 significant figures, which roughly, rounded to the nearest whole number, is 2. Okay, so this is just an estimate, and I'm doing it by hand. But well, let's do it on the other side as well. Let's see what the gradient would be somewhere else on the line, and let's try and estimate. Okay, let me pick another point, right? Let me pick this point here at -2. So I'm working out the gradient at x equals -2. Right, here's -2 on my line. Let me try to draw a tangent to this curve. So let me try and do it as best as I can. I need to be good with that's terrible, isn't it? It's just rubbish. Let me do it again. Maybe I need to get in closer to it. think that's pants as well. Let me do it again. Alright, you know what, I'm just going to accept that one, right, for now. It's not great, but again, I'm just doing it on computer. It's pretty hard to do, actually. You try it and you'll find out. Now, let's see what the gradient of this blue line is. Right, let me just pick the top point and the bottom point, and let me draw my triangle again. It's a really bad triangle, but my right angle triangle. Right, oh, this is going to be really tough to estimate. Right, this point, let's see. Let's say that there is minus 1 point, well, 0.5 is there, so let's say that's 0.6. Okay, and this point here, oh, I really wish I did this on graph paper, minus 2.4, let's see, that's going to be 0.5 there, 2.4, okay, that's minus 2.4. Now, so let's see what that gap is then, right? These are the two numbers on the x-axis, just need to work out the difference between them. So let me just work that out for you. Well, that's 0.8. Okay, that's the horizontal step, 0.8. Now, let's work out the vertical step. Now, be careful because this thing's going downhill. Now, I'm not sure how your previous teacher taught you how to do it, but if we start at this point, we're going down and then along, so we've got a negative distance to travel here. Whereas this one, we went along and went up. So, right, let me see. This point here is, let's say that there is minus 2.1 there. And then this point is, you know what, let's just say that's 5.5, right? Oh, so not, what did I say minus before? It's not minus, is it? It's just 2.5, isn't it? Oh, I've just done that. I don't know why I've done that. Right, okay. So it's just 2.5 and 5.5. Now let's work out this vertical step. So it's 5.5, take away 2.1, that's 3.4. Right, well, because it's going downhill, this side is going to have a negative gradient, right? So that's minus 3.4. Now, let's actually work out an estimate for the gradient at this particular dot. Minus 3.4 divided by 0.8. So that divided by 0.8 is 4.25. Okay, that's an estimate for how steep that tangent line is at that particular point. Again, I'm doing all of these by eye, so they're not very accurate at all. And even if you do it on graph paper, it still will be quite tricky to do. It's not the easiest thing to do, right? So 4.25 is an estimate for the gradient. Oh, no, it's not 4.2, it's minus 4.25. Whoops, I forgot that minus. Minus 3.4 divided by 0.8 is minus 4.25, right? So that's the estimate for the gradient there. Apologies for that, it's supposed to be negative, right? Okay, and the gradient at x equals 1 is 2. But you can see they're completely different numbers. So it's because of the nature of this graph, it's curved. So the gradient's changing all the time on this graph, okay? So it's never the same number in two different places. And then it's also changing sign. So you've got positive on this side and all negative gradients on this side. Right, but like I said, in the next clip, we're going to look at an algebraic way to do this. Okay, so a really sort of a way to do it so we get exact numbers rather than estimates. So what is the exact gradient here? What is the exact gradient there? Okay, a method of doing that. Right, I'm going to stop the clip and I'll see you in the next one.